Prove that root 2 is irrational number. See, already we know third form is always irrational. So here I'll solve this problem by contradiction proof. So contradiction proof is nothing but root 2 is irrational. So I'll consider root 2 as rational. Root 2 as rational. I'll solve the problem. I'll get wrong solution. So my assumption is wrong. Then I'll say root 2 is irrational. So first I'll consider. Let us assume root 2 is rational. Root 2 is a rational number. If it is a rational number, see, if root 2 is rational number, so rational number definition is a number which can be written in the form of p by q. So here I'll take like a by b. I'll consider root 2 is a by b, where a and b are co-primes. Where a and b are co-primes and b is not equal to 0. Now here, what do you mean by like co-primes? See, co-primes are the numbers whose HCF is 1. Whose HCF is 1. It means, for example, take 10 and 21. 10 prime factors are like 2 into 5. 21 is 3 into 7. So if you calculate HCF here, HCF will be like 1. So see, 10 and 21 are not prime numbers. 10 and 21 are not prime, but they are like co-primes. So what they want to say is 10 and 21, if I write in the form of p by q here, like this, a by b, I cannot cancel it further. Means there is no common factor between 10 and 21 except 1. So these are co-primes. This is only the main topic, because with this only we'll prove this root 2 is like irrational here. So I consider a and b are co-primes when b is not equal to 0. Fine. Next up, here I'll do squaring on both sides. Squaring on both sides. So see, root 2 equals a by b, like root 2 whole square and a by b whole square. So here square and root cancel, 2 equals a square by b square. So 2b square equals a square. 2b square equals a square. So see, 2b square equals a square. So see, a square I can divide with 2. So here I can say that 2 divides 2b square equals a square. So 2 divides a square. Then definitely like 2 divides a. For example, see, 2 divides 16, which is nothing but 4 square. Then definitely 2 divides 4. 2 divides 4. For example, 3 divides 36, which is nothing but 6 square. Then definitely 3 divides 6. So in the same way here, if 2 divides a square, 2 divides a square, then 2 divides a. So when 2 divides a, means the remainder will be, here see 0. 2 divides a. So the remainder will be 0. I'll consider the quotient as like here c. So I'll consider the quotient as c. Now see here. So if I'll apply division rule, dividend equals divisor into quotient plus remainder. So dividend is here a, divisor is 2, quotient is c, remainder is 0. A is equal to 2c. So here I'll consider let a equals 2c. A equals 2c. So here squaring on both sides. So again squaring on both sides. So you'll get a square equals 2c whole square. A square equals 2c whole square. So a square equals, it's nothing but here, so I'll write the next steps here. So a square equals 2c whole square is like 4c square. So if you'll see from here, a square value is 2b square. So this value will substitute here, this value. A square equals 2b square equals 4c square. Now if you'll cancel here, 2 times 1, 2 times 2. So you're left with b square equals 2c square. B square equals 2c square. Now here 2 divides, it's very clear, 2 divides b square. 2 divides b square. 2 divides b. 2 divides b. So see very clearly here, we got 2 divides a and 2 divides b. Both a and b have the common factor. Both a and b have the common factor 2. See, I consider a and b as co-primes, but here both a and b have the common factor 2. So, but this I consider as co-prime, so HCF should be 1, but here we are getting HCF as 2 because common factor is 2. This contradicts this conclusion you should write because our problem is done. This contradicts the fact that A and B are co-primes. This contradicts the fact that A and B are co-primes because we consider co-prime but we got common factor 2. And this contradiction arises because of our assumption. This contradiction arises because of our assumption. Because of our assumption, that is because of our assumption that root 2 is rational. Hence, we can conclude that hence root 2 is irrational. Hence root 2 is irrational number. So in this way we need to prove this.